we are going into lesson 1 related to empirical formula and molecule formula. So all students must follow the notes which is been provided to you, which you should be printed by now. And let's look at point number 1. The point number 1, what you need to do is you have to watch the video 1, which has given you the address there, which is 8 minutes and 30 seconds. You will be learning there the introduction for the molecule formula and empirical formula. And the video will explain to you what is the differences and how to write the empirical formula from the given molecule formula. Okay, you'll be supposed to stop the video and continue my point 2 later. Now we are going into point 2. Okay, definitions of empirical formula and definition of molecule formula. So what you can understand from the empirical formula here is it shows the simplest ratio of atoms of the different element present in the molecule of the chemical compound. Whereas the molecule formula is a chemical formula that shows the actual number of atoms of different element present in the molecule of a compound. Now, this is the 2 answers which are given you in your notes that you have to use as a definition if they asked you in exam. So you have to write word by word accurately. But it is going to be difficult for us to memorize it. Therefore, I came up with another table here which is going to explain to you how to understand the concept of molecule formula and empirical formula. You see, the molecule formula is the actual chemical formula, whereas the empirical formula is actually the ratio. Now, I've given you the example here, C6H12O6 is actually the molecule formula. So if you everything you divide by 6, you'll get CH2O, that will be the empirical formula. This will give you the ratio of the elements here. Now, how to write the answer script in exam? See, it shows the actual number of atoms of different element in a molecule of compound. This is molecule formula, whereas the empirical formula is it shows the simplest ratio of atom of different element in a molecule compound. So the definition between the 2 of them is differences in between using the word of actual number, and the other one is a simplest ratio. So this is about point number 4. Now we are going into the next one, point number 5, where all of you need to go and do the homework. So I've given you the homework, so this will be your answer. So you can copy the answer, pause the video, and you can copy this answer. So this is the answer for homework 1. Now I'm going into calculation. That's the second part of this chapter about calculations. Now under these calculations, okay, students, you should know that this is the steps that you have to write. The first step is actually to write the symbol of the element. Second is write the mass of the percentage of each element. Third is calculate the number of mole atom, okay, which is the mass or the percentage divided by relative atomic mass. And fourth, divide each number by smallest number to obtain the simplest ratio. And finally, you can write the empirical formula. So to find the empirical formula, you have to follow these 6 steps. But these 6 steps will be put into a chart form. Okay, I'll explain in the next example 1 to show you how we can actually do the calculation by using chart. Now, let's go to example 1. Now, if you look at example 1, see, they give you one sample, okay, one sample. Okay, you are given as one sample of iron oxide contain 5.6 gram of iron and 2.4 gram of oxygen. Determine the empirical formula of this compound. So you know that there is a 5.6 gram of iron and 12.4 gram of oxygen actually combine to form iron oxide. So now we need to find the empirical formula of this question. Now to do that, this is what we need to do actually. So first thing, the student should write the element is actually the iron and chlorine, and we need to, second column is the second row is actually the mass or the percentage, and this question the iron is actually 5.6 gram and the mass of the oxygen is 2.4 gram. So the number of mole atom is actually mass over RAM, that means relative atomic mass. The mass here is 5.6 and the relative atomic mass of iron is 56. So 5.6 divided by 56, you'll get 0.1. Where else for chlorine you get 2.4 divided by 35.5, which is equal to 0.15. So the number of mole atom for iron is 0.1 and this is 0.15. So what you do is I divide everything by 0.1. The smallest value here in between these two values is 0.1. So 0.1 divided by 0.1 is actually equals to 1. That gives you the ratio. But this ratio here 0.15 divided by 0.1, you get 1.5. And this is not in an integer. So what I did is from here to here you times with 2. So when you times with 2, the 1 you times with 2, you get 2. So 1.5 you times with 2, they'll get 3. Now the both of them are in integer. So the empirical formula is Fe2Cl3. So this is the answer for example 1. I hope everybody understand this. Let's go to example 2. So in an example 2, in example 2, we need to calculate one of the chemical compound, which is magnesium chloride, contain 25.26% of magnesium, and determine the empirical formula of the compound. So now here we got magnesium chloride. The magnesium chloride, and we only know the percentage of magnesium is 25.26. So since the percentage of magnesium is 25.26, therefore the percentage of the chloride, percentage of chloride is 100 minus 25.26%. So that gives you the percentage of the chlorine. That will be about 74.4%. Now to solve this problem, again we need to go back to the table. We need to go back to the table, which the table contains of element. Element, magnesium and chlorine is an element there, and the percentage of magnesium is actually 26.26, and chlorine is actually already minus here, under minus 25, you give 74.25, that will be 74.74 will be the percentage of the chlorine. Now you can calculate the number of mole atom by using the percentage value, and imagine this is as a gram, and relative atomic mass of magnesium is actually 24. So 25.26 divided by 24, you get 1.0525. Whereas for chlorine, the percentage is 74.74, and relative atomic mass of chlorine is actually 35.5. Then this gives you 2.105. Now if you compare these two values to find the ratio, this is the smallest value. So divide by smallest value. That means 1.0525 divided by 1.0525 will give you 1. Whereas 2.105 divided by 1.0525 is actually equals to 2. Therefore, the empirical formula is MgCl2. So this will be the empirical formula of magnesium chloride. Now we are going on to the example 3. When you talk about example 3, so what we have here is an organic compound. So what is the differences with the example is, the first example are discussed with the mass, which is in a gram. The second example are discussed with percentage. But the third example I'm talking about, instead of using 2 compounds, I'm using 3 compounds. See, we have a carbon, hydrogen and oxygen, where they're given the compound formed by the combination of 3.96 gram of carbon. So 3.96 of carbon here, and hydrogen here 0.66 gram of hydrogen, then 0.66 here, and oxygen is given as 3.52 gram of oxygen. This means 3.96 carbon, 0.66 gram hydrogen, and 3.52 gram of oxygen is combined together to form the compound. So we need to find the empirical formula. So what you need to do is you need to include more columns, that is one more extra column for oxygen. Now we already got the mass. Now we're going to calculate your number of mole atom. So number of mole atom for carbon is 12 divided by relative atomic mass is 12. So 3.96 divided by 12 is 0.33. Hydrogen is 0.66 divided by 1 because the relative atomic mass of hydrogen is 1. So you got 0.66. And oxygen is 3.52 divided by 16, I got 0.22. But in this case, I'm being divided by the smallest value is 0.22, but I divided by 0.11. Because I can divide everything by 0.11, this will provide me the ratio in an integer. So I divide by 0.33 divided by 0.11 will give me 3, 0.966 divided by 0.11 will give you 6, and 0.22 divided by 0.11 will give you 2. Therefore, the empirical formula is C3H6O2. So 3 just follow here, and you will get the empirical formula. So now we continue with example 4. Okay, we talk about example 4. So I'm talking about, in this question, I'm already gone into the application of questions. That means a question which is been using the empirical formula, but we're going to calculate something else. It's not an empirical formula anymore. So we already provided with the empirical formula. So here you see 0.5 mole of R combined with 3.6 gram of oxygen. That means you see here in this question, the R already been calculated. See, they didn't give you the gram. The R is already been in a 0.45 mole. So I straight away I put that 0.45 mole as a number of mole atom. And the only thing is oxygen given as a 3.6 gram. Therefore, I'm taking a 3.6 gram divided by 16, I got 0.225. So I got 0.45 and 0.225. The smallest value is 0.225. I divide by 0.225, I got 1. And here I got 2. Therefore, the empirical formula is R2O. So now you look at it. Here they already provided the 0.45 as a number of mole atom directly. So we no need to do calculation. We only fill out the second column. Okay, and the second row of the table. Next example. We are going into the example number 5. See, in this example, you are provided with 2.5 gram of metal Y combined with X gram of oxygen. See here, you are given X gram of oxygen. That means we don't know what is the number of gram oxygen is reacted with the metal Y. And you are given that the empirical formula is Y2O. Okay, find the value X. That means we need to find the mass of the oxygen. So in this case, again, we create the same table. See, we got element Y and O, and the mass is here is 2.5 gram and X. So we calculate normally. So that means the Y must be divided by 23 because given here relative atomic mass is actually 23. So divide by 23, you got 0.1087. But for oxygen, I know that relative atomic mass is 16. Therefore, X divided by 16. So this ratio this. But we already given the formula as a Y2O. So this is the molecule formula, which is also equal to empirical formula. They are same. So therefore, we got that Y2O is empirical formula with the ratio of Y will be 2 and ratio of X O will be 1. So now we know that since the molecule formula is Y2O and the empirical formula is Y2O again. Therefore, this divided by this, that means this part, the relative atomic mass, number of mole atom of Y divided by relative number of mole atom oxygen will be equivalent to 201. So what I did is remain this part, and 201 is 2, then this whole thing, okay, is times here. So I get 2 times with x over 16. So we cut here, I got 1 time, and this is 8 times, then 8 times here. So 8 times with 2.5 over 23 is 0.1087. So 8 times of this value will give you the x value as 0.87 gram. So this will be the mass of the oxygen that reacted with element Y. So this is a example 5. Okay, let's continue to example 6. Okay, now we are going to example 6. That is point number 12 in your notes. Okay, if you look at this example, I've actually given you another type of example where the informations about nitrogen is not being provided in terms of mass or in terms of a percentage. Now I'm provided in terms of volume. That means 224 centimeter cube of nitrogen gases reacted with 672 centimeter cube of hydrogen. Gas is measured in a STP. So STP means 1 mole of any gas is actually 22.4 mole dm cube. See, the gas will apply to 22.4 dm cube. Now how are we going to do it? You still do the same way. You need to build the table again. Okay, we form the table now. So we have an element, nitrogen and hydrogen. Nitrogen is 224 cm cube. Instead of using here mass, I'm using volume. Instead of using percentage, I'm using volume now because question given in a volume. Then hydrogen was 672. So now to find the number of mole atom, since 1 mole gas is 22.4 dm cube, which is equivalent to times with 1000. So you get 22.4 times with 1000 times divided by 1000 and 672 divided by 1000. So you will get, cut these two values because the denominator is the same. So you get the ratio as 224 divided by 672. And I'm going to take a smallest value, 672 divided by 224. That provide me 3. Therefore, the ratio is 1:3. So therefore, the empirical formula of ammonia gas is actually NH3. So this will be the answer for the example 6. For the last example for this section is example 7. Okay, you are looking into example 7. In example 7, you are actually looking at the question again. An oxide of chemical formula GO2. That means you're already given the empirical formula and also the molecule formula, which is contain 92 gram of G. So 92% of G, it means the oxygen is 8%. So that total up is actually 100%. Even though the percentage of oxygen not provided, but it is actually 8%. So find the relative atomic mass of G. So in this case, the relative atomic mass of the G is not provided, so we need to find that. So now again, table, element G and oxygen. Percentage is actually 92 and 8% of oxygen. We calculate number of mole, 92 divided by G, which I cannot get the value. And 8 divided by 0.6 is actually 0.5. And the ratio should be 1:2. 1:2 because the empirical formula is GO2. That means G is 1 and oxygen is 2. Therefore, you'll be getting 92 over G divided by 8/16 will be equivalent to the ratio is 1:2. That means 1 divided by 2. So I take the 0.5 and times here. That means 0.5 times with 1/2 is actually 1/4 because 1/2 times with 1/2. 0.5 is 1/2, so times with 1/2 you get 1/4. So I'm taking the 4 and times with 92, so got 92 times 4, and G I times with the 1, I will get G. Therefore 92 times 4 you'll get 368 gram. That means the relative atomic mass of G is actually 368 gram. So we have done the calculations for part 1. Now we're going to continue with the calculation for part 2. This is actually practically you need to go about how to determine the molecule formula from the empirical formula. See the calculations of molecule formula, which we have a step 1 and step 2. To calculate the n value is a relative mass of molecule formula divided by relative mass of empirical formula. So we got a formula. If let's say the empirical formula is XAYB, then the molecule formula will be equivalent to the empirical formula N. And let's say empirical formula is XAYB bracket N. So the N times with the A, so you get XAN, YBN will be the molecule formula as given in your formulas. So this is the 2 steps that you have to do in order to find the molecule formula from empirical formula. Now we take example 1 here. That's a point number 15. Okay, you are provided with calculation. You are given with A, B, C, D, E. That's 5 examples here. The empirical formula is CH2. The relative molecule mass is 180. So now we need to calculate relative empirical mass is actually CH2. C is what? 12. Hydrogen is 2 because 2 times 1, and oxygen will be 16. So you plus all of them. So 12 plus 2 is 14. 14 plus 16 is actually 30. Okay, you get 30. So to calculate the n value, this must be RMM divided by REM. Therefore, this will be equivalent to 180 divided by 30. So that's give you 6. Okay, that's give you the 6. Therefore, the molecule formula is CH2O bracket 6, which is equivalent to C6H12O6. So that will be the answer. So this is being given here. Okay, CH2 molecule relative here is 30 and 180 divided by 3 is 6. Then you put the 6 and calculate this. Now we can go to example B. Okay, we look at example B. Now CH2 is what? 12 plus with 2. So 12 plus with 2, you'll get 14. So 42 divided by 14, you get 3. So CH2 3 is what? C3H6. That will be example 2. Example C, Na2O. And relative molecule mass is actually 62. And N is what? 23 times with 2 plus with 16. That give you again 62. So 62 divided by 62 is 1. That means the n value is 1. So 1 times 2 is 2. 1 times 1 is 1. Therefore, you get the same as the empirical formula. The molecule formula and empirical formula will be the same because the ratio is 1. So the formula is Na2O. The next example, NH3, you are given relative molecule mass is 17 and relative empirical mass is actually 14 plus 3 times with 1. That's also 17. Ratio is 1. Therefore, the molecule formula is NH3. And lastly, we have C3H8. And relative molecule mass is provided as 44. And you calculate here 3 times with 12 plus 8 times with 1. You get 44 also. Therefore, 44 over 44 is 1. Therefore, the molecule formula is C3H8. So this is how we find the molecule formula from the empirical formula if you are provided with relative molecule mass. So without giving you the relative molecule mass, you can't solve the formula of molecule. So now we go to the next example. Okay, next example. Example for point number 16. you have to watch the video which is provided here and answer your question A, B, C and D. Okay, that's 4 questions which is related to the video. So you go through the video and answer the question. Let's go to next example. Point number 17. Okay, point number 17 for relative molecular mass. There's 2 sections here that we need to answer. The first question. The tobacco contains nicotine. The chemical analysis of the compound shows that nicotine contains 74.1% of carbon, 8.64% of hydrogen, and the rest is nitrogen. So they ask you to determine the empirical formula of nicotine. Now, to find the empirical formula of nicotine, you are given that 74.1% is a carbon, 8.64% is hydrogen. Therefore, you must take, to find the percentage of nitrogen is 100 minus 74.1 minus 8.64. That gives you 17.26. Okay, that gives you 17.26. Therefore, now we will calculate relative number of mole atom. Carbon is 12 divided by 12. Here is hydrogen divided by 1. And nitrogen is divided by 14. You'll get 6.175 mole for carbon, 8.64 for hydrogen, and 1.233 for nitrogen. And the smallest value among all these 3 is 1.233. Therefore, to find the ratio, everything divided by 1.233. So you will get the ratio of carbon is 5, hydrogen is 7, and nitrogen is 1. So the empirical formula is C5H71. Okay. Now we are continuing with next. Okay, we are continuing with the next part. That will be the second part of the question. You know what's the second part of the question? The second part of the question, they ask you, if the relative molecular mass of nicotine is 162, what is the molecule formula? So that means you are given, need to find the value of N. Relative molecular mass is 162. Therefore, we have a 5 carbon here, so 5 times 12, 7 hydrogen, 7 times 1, then 1 nitrogen. Nitrogen relative atomic mass is 14. So 162 divided by 81 is 2. Therefore, the molecule formula is the empirical formula N. So N is 2. So times the 2 inside. So 2 times 5 is 10, H is 14, and N is 2. So this will be the empirical formula, molecule formula of nicotine. Okay. So now with this, you can answer all kind of calculations that we need to know for your SPM under your pass here. So this is the example that you require for empirical formula.